Hello. This is Christopher Parham from the Endless Sphere Forum. This podcast will explain my past experiences with wire and connectors over the past years in the electric bike hobby. There was a time where I was very young and naive and experienced some very fundamental mistakes when it came to wiring my electric bike. Here are some of them over the years. Let's start with our cheap friend PVC. Once upon a time PVC was my go-to wire. I had a golden motor front hub motor. I ran many different battery packs in series and parallel. I was running the run-of-the-mill 45 amp controller. The wires in my little rack bag were alright for most of the time. As I got deeper into the hobby and started building larger battery packs and went on longer rides, I started to have random failures. One was with the PVC wiring. At the time I believe I had 12 gauge wiring originally with a 20 or 25 amp controller. When I swapped the controller to a bigger one I stayed with the same gauge wire. This turned out to be a big mistake with the 45 amp controller. With the increase in current and the tight enclosed space of my battery bag, the wiring insulation started to melt and stick to each other. When the ride was over and I inspected my batteries, to my surprise I had several wires stuck to each other. Pulling them apart reminded me of Twizzlers pull and peel. This prompted me to go up in wire size up to 10 gauge wire. This helped the situation drastically, but the wiring sometimes still got too hot for comfort. They weren't sticking together anymore, but boy were they soft and still very pliable. Getting into the hobby at the time was a very expensive task, but with guidance of a fellow electric bike rider it was drilled into me if I wanted reliability then I had to spend the money or reliable tools, components, and supplies. He told me to get some silicone jacketed wire. And so began my love with silicone. Still being cheap at the time I bought 12 gauge silicone wire. This had the current capacity I needed at the time and the price was right. Also at the time I was introduced to Anderson connectors. This was fine for my friend at the time, which had no interest in going fast. He had a plain Jane stock electric bike kit that suited him very well, but I had the fever and was on the quest for speed and power. The wiring was doing great, but over time I started melting and wearing out Anderson connectors. These were supposed to be rated for 45 amps. What gives? What I failed to realize with 45 amp Anderson connectors that they were only reliable with 10 gauge wire and that it used the wire to heat heat away from the connector to improve its durability and reliability. This prompted me to do another upgrade to 10 gauge wire. I had silicone wires and Anderson everywhere it seemed. At this time I'm riding like a boss with very little trouble and an extremely fast 35 miles per hour bike. By this time I believe I was experimenting at 66 volts and 88 volts and 45 amps. So I was well into the sickness at this time. At an age where programmable controller were becoming a thing, I had a Lion 12 MOSFET controller that I was pushing to the limits of 40 to 60 amps battery and 90 to 120 amps phase. My battery wiring was fine, but my motor wires were hot and the Andersons were failing. The curse strikes again. Being an active reader on the forum, I began reading on what people were doing with phase wires. Other members were cutting the motor harness right outside the motor axle and putting connectors right there. Not any connectors, 4mm bullet connectors. They would then extend the wires to the controller with much heavier wire. The standard gauge for phase wires at the time was 16 gauge PTFE. I extended the wires with 10 gauge silicone all the way to the controller with 4mm bullets on each end of the extensions. Also at this time I started doing something different with my motor phase wires. I actually took them out of the axle completely. I would strip the black sheathing off and heat shrink each phase wire and bundled the Hall wires for the length that goes through the axle. This gave it a bit of extra protection against abrasion and shorts for the amount of power I was about to throw at it. This gave me a trouble-free season until next year, where I switched to something new. The year of the Pi. With all I had learned I was pretty confident with my skills at the time. I developed the motto: anything worth doing is worth overdoing. And also, if you don't have time to do it right, then you better make time to do it over. Every year I pushed myself and my equipment. I would take underdog motors and pushed them to their limit and then figured out how to make this limit continuous and found a happy compromise. This year the victim was a Magic Pi 2 motor from Golden Motor. All the tricks that I used over the years came into play, and then I took it a step further. I was running a Tune 3077 12 MOSFET controller tuned to 65A. I recently started to use XT150 connectors. I also started using 10 gauge and 8 gauge silicone wire exclusively on battery and phase wires. By this time I was a pro at creating one-plug series parallel battery harnesses. I've done what seemed like hundreds for other fellow Endless Sphere members, but never really used them myself because the 45 amp Anderson was too small for the current that I was running. So say hello to my bigger friend, the PP75 Anderson connector. This monster connector was a bigger brother to the 45 amp Anderson, and like its name suggests, it was rated for 75 amps. This made charging and discharging my battery packs a breeze, but it came at a cost. The retention force on these connectors is 50 pounds per connector. So trying to unplug one giant plug for 66 volts took 300 pounds of force. I later split the plugs into 3 sets, dropping it down to 100 pounds force, which was a lot more manageable. This season was uneventful. Thus ending this chapter. Here are my personal views on connectors commonly used on electric bikes. Those original bullets that come standard with electric bike motors and controllers are a joke and should be discarded immediately. No if and or buts. Over the years there have been many struggles with 45 amp Anderson. One problem was with the spark of plugging in controllers. This pitted and wore down the connector. It seems like 45 amp Anderson didn't last very long. As I upgraded to beefier connectors over the years, this was less and less of a problem. 45 amp Anderson also had to be seated perfectly to where it mated with the other connector perfectly. If it was the slightest bit off, then you lose contact surface area, making it a high resistance connection, and even with 10 gauge wire there was still a chance that it would overheat and melt. Even under best conditions the contact and spring tension would fade and they would need adjustment with a small screwdriver. This connector is okay, but I would derate it and use it for 20 to 35 amp stuff. These are not gendered, so any individual connector can plug into any other mating Anderson connector, but if assembled correctly and color coded you can key the plug so they can only be plugged in a certain way, and also use the color matching as a second reminder or confirmation that it's plugged in correctly. 4mm bullets are great for their size. I would upgrade any motor phase wires to 4mm bullets minimum. But his connector has a questionable rating. Some say 60 amps from their own personal opinion. Hobby King says 92 amps. My load station uses these, and under heavy use at 45 to 50 amps under a continuous load it can reflow the solder on the connector with proper 10G wiring. But again, my opinion, with use on electric bikes we rarely have a constant load lasting more than 20 to 30 seconds, and connections like those for the phase are exposed to air. This increases their rating. But these I would say a solid 40 to 60 amps for electric bike use. These are okay for battery connections, controller connections, phase wire connections on sub 45 amp bikes. They are gendered connectors, so it makes it hard to plug it in wrong. They have housings. They come in several variants. Naked raw connectors. Unloaded, meaning you get connectors that you snap or insert into housings after you solder them. And loaded, meaning the contact of the connector is already inserted into the housing and you solder onto the exposed cup on the rear. You must heat shrink this to prevent shorts. The loaded and unloaded ones have nylon housings. I personally use XT150. I put that shit on anything carrying any significant current. It's a 6.5mm connector capable of carry up to 250 amps with the proper wire. Meaning 6 to 8 gauge. I often use it with 10 gauge but at lesser amps. They have nylon housings. You can create a gendered plug combinations to make it impossible to plug your stuff up the wrong way. They can slide together and you could heat shrink them to make a nice solid plug also. They have a variant called the AS150 that's an anti-spark connector that can be used up to 50 volts. 5.5mm bullets are sometimes found on some battery packs from Hobby King. I never really use them on a bike too much. Most variants don't have housings. Can be used with 10 gauge to 8 gauge. 8 gauge is a stretch, but it's possible. You can use an old 4mm bullet housing to create protective heat shrink shrouds that are very effective against short protection if done correctly. There is 8mm bullets, which is a little short stubby ass connector with a cup that can accept 7.5mm worth of wire. So this is good for 2 to 4 gauge wire. Some styles have no housing. You have to get creative with heat shrink to protect them from accidental shorting, and even that is by no means foolproof. They are gendered male and female. I never use them, so I don't have much to comment on. There are XT60 and XT90 connectors. Both imply their rated amperage. XT60 can handle 14 to 10 gauge wire. XT90 can handle 12 to 8 gauge wire. They are gendered and can only be plugged in one way. Easy to solder. Must use heat shrink to cover your soldered connection, the rear of the connector. They have nylon housings. These connectors do have anti-spark variant that can be used on 50 volts or less packs successfully. There are copper lugs. These are normally used with, let's say, 8 gauge wire and up. These are very robust connectors that I would use on Kelly and Sab button controller that have screw or bolt on terminals for battery and phase. These are normally assembled by locking the lug into a vise and using a butane or propane torch and filling up the cup 50 to 75% full of solder and then slowly immersing you fluxed wire into the connector. Heat shrink it and you have a connector that would make Tesla proud. XLR connectors are those connection used on some batteries from China. Decent for low amp charging. 5 maybe 10 amps or less. Should not be used for anything else. Those are the most popular connectors at this time that I can comment on. Let's go on to wiring that's available for electric bike use. There is PVC wiring. This is rated for 80 to 105C. Very low current handling. Only to be used on the basic builds with up to 20 to 30 amps. This insulation type melts at very low temperature, so it can't handle a lot of current. If you try to push a lot of current, the insulation will get soft and tacky. The strand count is low to moderate. It has some flexibility but may have a bit of a memory. Especially in colder situations. Silicon wire, which is the hobby grade standard for most RC applications and mid to high grade electric bikes. Also called noodle wire. It's very limp and lifeless. Resembles cooked spaghetti noodles. The strand count is pretty high, which aids in its flexibility. Very heat resistant and flame resistant. This makes it very good at passing amperage exceeding the limits of normal wire for extended periods of time. In my opinion, 10-gauge wire handles most of electric bike needs. It is smaller than I would like for continuous duty, but electric bike loads are dynamic with most of the high current happening on acceleration or very heavy loads. If the bike is configured correctly, the current will taper to 50% or often much less of the max rating of the controller and the wiring. I believe it is acceptable to use 12 to 8 gauge silicone depending on the demand of the build, with a few exceptions of people seeking every ounce of power which they need to drop to a gauge lower than 8 gauge. Jacket thickness is pretty substantial, normally thicker than PVC and PTFE. Not really good for phase wires through the axle, but can be used for extensions. PTFE wire is a good wire, but it is only good for one thing as far as I'm concerned. Phase wires for the motor. This is a very high temperature wire. Flame resistant. High temp resistance up to 200 C. Downside is the heavier gauges are very low strand count, which makes the wire super stiff. PTFE isn't very flexible either and has a memory. Due to the insulation not being flexible and the strand count being low, they typically have a very thin jacket. Larger gauges have good abrasion resistance, then it hits a gray area with certain cables to where it can be easily nicked and could cause shorts to the motor axle. Wiring gauge versus volt drop. In my research and calculations, the losses are very small. For an absurd length of 10 feet of wire, I calculated the following for me: at 75 volts and 80 amps using a 14 gauge wiring, there was a 2.69% loss in the wiring on the battery side before the controller. That's 223 watts lost as heat. Using 12 gauge, 1.69% losses for 101 watts lost as heat. Using 10 gauge, 1.07% losses for 64.2 watts lost as heat. Using 8 gauge, 0.67% losses for 41 watts lost as heat. It's my conclusion that the losses are negligible and going to a bigger wire isn't netting much if any usable power to the ground. You lose what, maybe 20 RPM from your top speed. This is worst case scenario using horribly 10-foot long 14 gauge wire. I also must remind you this is calculated for 10 feet of wire, which is stupid amount of wire to have on a bike. You can drop the values linearly almost, so dropping it down to 3 feet would be a third of the mentioned values above. Where it does make sense to upgrade e-bike wiring is the wiring going from the controller to the motor phases. These are subjected to low voltages at very high amp loads during acceleration. When a motor is accelerating, the controller is PWM the motor at low voltage and high amps to get it going. As the RPM increases, the PWM changes and the voltage rises, and amps start to decay as RPM increases due to BEMF. But under low speed, where the volts are low and the amperage is at its max, occurs massive losses. At let's say 10 volts phase and 160 amps current, losses can be about 12% on stock 16 gauge phase wires. As the PWM changes and voltage increases, this drops down to about 2% at top speed. By increasing phase wire gauge to let's say 8 gauge, the losses drop to 2% starting up and 0.27% at top speed. With 8 gauge on the battery and 8 gauge on the motor phase side of things, the 2 volts gained from both sides might gain 1 mile per hour top speed due to there being less volt drops. But going to a higher gauge like 6.4 or 2 gauge, the gains are negligible. Going on to high resistance connections, if people are having problems with a wire coming loose from a connector, then they are more likely pulling too much current through the connector, and the connector doesn't have enough of a contact surface to transfer the current efficiently. Basically, a high resistance connection, where there is resistance there is heat. Where there is a significant amount of heat, you are going to have a bad time. Solder varies in quality. I use 60/40 lead tin at Wixwell, and you can use a lower temperature. Lead free melts higher and safer for people to use overall, but it can be a pain to deal with. Solder has a working liquid range, and then there is a range where it's like a semi-solid or pliable. On a poor connection, it's possible for the connection temperature to reach the temperature for the solder to become pliable and or reflow back into a liquid state. This means a connection under heavy load and vibration could come loose and cause a failure. There are ways to counteract this. Using the proper connector and wire for the load. By using a larger wire to heat sink the heat away from the bad connection, this is a bad practice. Some of the methods are ideal and some of them mask or hide a problem. If a connector is getting hot, there is resistance somewhere and significant volt drop has occurred. Just because you use a larger wire and the connector isn't failing anymore because the larger wire is heat sinking the heat away and the connection is at a lower temperature, there still lies a bad or inadequate connection not able to carry the current properly. So if you do plan to go up in wire size for whatever reason, use appropriate connectors. If you don't, then your wire upgrade will be for naught if that bad connection still exists. Using a different solder formulation that can withstand higher temperatures can also help. This is also treating a symptom and not the problem. Sometimes there is a cold joint. One must tin the wire and the cup and make sure flux is applied to ensure proper wetting. If this isn't done, a cold joint, although it may seem somewhat solid, is still a bad connection that will heat up and possibly will break loose, reflow, and fail. On certain connectors like XT150, 5.5mm, 6mm, and 8mm bullets, the prongs on the male connector can get smashed, causing uneven spacing. This can cause a bad connection and drastically derate the connector. To fix this, one can take an appropriately sized screw and thread it down the center of this male connector, and it will respace the prongs evenly. A small screwdriver can accomplish this also. When crimping wiring, make sure you use proper sized wire. Going too big or too small can cause a failure from a proper crimp. When possible, crimp and follow up with solder for a connection that will stand the test of time. Anderson connectors are prone to failure when the correct gauge wire isn't used. The wire can pull out the back of the contact. I personally often follow up with solder if I know the connection will be stressed or the wire size is slightly questionable for proper use in a contact. This is all I have for now. Thanks for listening.